Hi friends, welcome back to my channel. As I have promised from our previous video that I will be back with another exercise based on compressors. Still on power machines and 5. My name is Tsepo. Please don't forget to subscribe to my channel. Click that notification button so that you'll be notified every time I post a new video. And don't forget to share this video. And then we will be doing an exercise today from my textbook, which I'm using, and it's exercise 17 number 3, and it reads as follows. A single cylinder, single acting air compressor has to deliver 4.1 cubic meters of free air per minute. The air is compressed from 101 kilopascal to 1010 kilopascal. Index of compression N is equals to 1.3. Clearance volume is equals to 6% of the stroke volume. Piston diameter is equals to 0.8 of the length of stroke. Compressor speed is 260 rads per minute. Consider the suction pressure and temperature to be that of free air and calculate. So they gave us the information of the air when it is coming into the system. They gave us the pressure and the volume, and then they gave us the pressure of the air when it is now leaving the cylinder. They gave us the index. They gave us that the clearance volume is equals to 6% of the swept volume. They gave us the diameter in terms of the stroke length. They also gave us the speed. So they said question number 1, we must calculate for the volumetric efficiency. That it's A. They say we must calculate for the volumetric efficiency, and the formula for volumetric efficiency is equals to the effective volume divided by the stroke, or the swept, the stroke volume, which it's given by V1 minus V4, and this is given by V1 minus V3. So first things, we must calculate for the stroke volume and the swept volume. So we know that there is a formula where we can find the stroke volume, since we are given the amount of volume per minute that comes into the system. And then we know that the volume per minute, it's equals to the effective volume times the speed, which is rads per minute, times the cycle. So the number of cycles, I didn't write it, but the number of cycles, they said it's a single acting, single stage single acting, which means it's 1. So we want this, we must make it the subject of the formula. EV, it's equals to V volume per minute divided by the rads per minute, which is the speed, times the cycle. And then we substitute our volume per minute, it's 4.1, and then divided by our speed. Our speed is 260 times 1, which is the cycle. And then I got that my answer for this is 0.0158 cubic meters. So we are done with our first volume. Now we must calculate for our swept volume. So there is a formula like this. Swept volume, it's equals to the area times the length, which is pi, I think it's pi squared divided by 4 times L. But in this case, since we are not given the the diameter of the cylinder and the stroke length. We are given the cylinder in terms of the stroke length. It is not going, this formula won't be helpful for us at this stage. So we must go to the graph, since we know that the swept volume is from here to here, which is V1 minus V3. And then since we are given, we know the value of V3, we can go to the equation and substitute. V1 minus our V3 is going to be 0.06 SV. And then this is SV. Then we simplify this. It's going to be 1.06 SV. And then we know that our effective volume, our effective volume is equal to V1 minus V4. So now we have V1 and it is given in terms of SV, and we have the effective diameter, the effective volume. So if we can find our V4 and substitute here, we can be able to calculate for our SV, which is what we are looking for us to be able to get the volumetric efficiency. So we come and calculate for our V4. So remember, if you are looking for any information between these points, point 4 and point 3, or point 1 and point 2, since they are being performed using polytropic law, we can be able to get that using the formulas of polytropic. And then in this case, we will use the formula V3, P3, V3, N is equals to P4, V4, and then N. So since we are looking for this, we make it the subject of the formula. V4, it's equals to it's going to be equals to what? We make it the subject of the formula is V3, and then it's P3, yes, divided by P4 raised to N 1 minus N, and then we substitute our V4. It's going to be V3, which is this. Our V3, we know it's this 0.06 S, 0.06 SV, and then times our P3. Our P3, this is going to be our P3, 1010 divided by 101, which is this. And then it's 1 divided by our index, which is 1.3. And then we get the answer. Our answer, it's 0.353, and it is also given in terms of CSV. So since we are looking for SV, this is not going to be a problem. We come to this formula and substitute the value of V1 and the value of V4. Then we will have something like this. From this, V1 minus V4, it's equals to 0.0158. And then we say the value of V1, it's somewhere. Where is it? This is the value of V1. 106 SV minus the value of V4, which is this 0.353. It's equals to 0.0158, and then we minus here the answer that we get. We divide both sides, and then our SV is going to be 0.0223 cubic meters. And then from here we have SV, and then we have the effective volume, which is this one. So from there we can go and say our volumetric efficiency, it's equals to E effective volume, it's 0.0158, and then our swept volume, this is our swept volume, is 0.0223, and then our answer times 100 times 100, yes, and then our answer is 70.9%. It's 70.9%. That's our volumetric efficiency. And then our second question, they say we must calculate for the piston diameter. So I will go ahead and erase this thing. We are done with it. Yeah, we're done. Okay, we are not. We will need this. Our swept volume, it was our swept volume. We got, what did we get for swept volume? We got 0.0223 cubic meters. So they said we must calculate for the diameter, and then they gave us this. They gave us that the diameter, it's equals to 0.8 of the stroke length, and then we know that the swept volume we can calculate using this equation, which is area times the stroke length, and then our area, it's equals to this stroke volume, the diameter squared, times the stroke length. And then now, since we want the diameter, let's make the stroke volume the subject of this formula, where we will get that the stroke volume, it's equals to 1.25 of the diameter, where we will divide both sides by 0.8, and then we will get this formula. And then we come to this equation, we divide, we substitute, we say pi divided by 4 times d squared, and then instead of L we put this 1.25 d, and then we have the value of the swept volume, which is 0.0223. And then if we take a look at this equation, the only unknown that we have is the diameter, the same diameter that we are trying to get. So we simplify, we make the diameter the subject of the formula. Okay, let's put SV first and then make the diameter the subject of the formula. We will get something like this, and then it's SV times 4, and then it's pi times 1.25, and then from here we can calculate for our diameter, where our swept volume is equals to 0.0223 times 4, and then our pi times 1.25, and then they said you must calculate for our diameter in millimeters, and then I got that my answer is 283.205 millimeters. And then that's our number B. Then our number C, they say we must calculate for the the length of the stroke, also in millimeters. So we come to this formula. That's our number C. We come to this formula. We say our L, it's equals to 1.25 times the value of our diameter, which is 283.205. And since this is in millimeters, our answer will also this answer will also be in millimeters, so no need for convention in this part. And then I got that the answer is 354.006 millimeters, and then this is our answer. Oops. Yeah, and this is our answer, and that's the end of our question, and it's basically the end of our lesson. Hope this video will be of help to you. Don't forget to subscribe to my channel if you are new here, share this video and like it. Also comment, tell me what you think about today's lesson. From me to you, I will see you on the next lesson. Ciao.